So hello guys, welcome back to the channel. So in this video we'll be learning about uh, what we mean by machine learning, and we'll learn the subparts of machine learning, and we'll learn the types of machine learning. Okay, so first we'll be seeing the definition of machine learning. Then next we'll be seeing about the applications of machine learning, like where all ML is used in our daily lives. Next, we'll be seeing the difference between ML and traditional programming. And next, we'll be seeing AI, ML, and deep learning. Then next, we'll be seeing about the types of machine learning, that is supervised, unsupervised, and reinforcement learning. We'll be seeing each one of them in detailed manner. And next, the last step we like we're going to see is like how an ML model is being built. Okay, so we'll see each one of them one by one. So what do you mean by machine learning? So the machine learning means it is a subset of artificial intelligence which enables systems to learn from data, identify patterns, and make decisions with minimal human intervention. So what do you mean by this? So basically, machine learning, it learns from huge data and it creates patterns to understand that data. Then lastly it gives the output. Okay, in simple words I would say a machine learning is a subset of AI which creates patterns from huge amount of data and it creates the output. For example, if you want to detect which mails are spam and non spam, then we give the label data to the machine learning model. Okay, after giving the data to the machine learning model, the machine learning model, it what was it understands from the data. It understands from the data like which mails are spam and non-spam. How? Because we have already given the label data. Now, what do you remember label data? Label data means we defined like which emails are spam and not spam. We defined each of the emails. So this same data is given to the machine learning model. Then the machine learning model it understands like which mails are spam and not spam. Okay, so the machine learning model it understands. Basically, it understands that these mails are spam and these mails are not spam. Okay, so by this the classification is being done between these two mails. Got it? So this is nothing about machine learning. So the next part which you're going to say is the applications of machine learning. So where the machine learning is being applied in our daily lives. So we can see the first example is personalized recommendations. So what do you mean by personalized recommendations? So as you can see, when you order one item from Amazon or Flipkart, then that same product will be suggested during our next search. Okay, so this is nothing about machine learning. Okay, and the next example I would say is uh, autonomous vehicles. So, what do you mean by autonomous vehicles? So, autonomous vehicles means self-driving cars. For example, I would say now Tesla. So, basically, the machine learning model is being fit into the car so that the car can understands uh, the pedestrians and it can understands any objects in front of the car. Okay, like it be knowing like when to take left and when to take right and when to stop. So this is all done by the machine learning model. Okay, next I would say is it is used in medical diagnosis. So How so basically nowadays machine learning is used in medical field, like for example, uh, if we give an image to the machine learning model, okay, if we give an image of what, if we give an image of the disease to the machine learning model, then the machine learning model, it identifies the type of disease present in the image, which means it, by observing the image itself, it identifies the types of disease and it also gives the treatments to that particular diseases. Okay, and this and these results are accurate. Like it's like it acts as a supportive system for doctors. So this is widely used by doctors and hospitals. Okay. Uh, so the next application is, it is used in spam filtering and security. So as I told you, like spam emails and mails, the machine learning models, it automatically blocks the spam mails and it allows the user to access only the non-spam mails. Okay, so this is another application of machine learning in our daily life. So the next part which we'll be going is, so what is meant by traditional programming and machine learning? So in traditional programming, the programmers write detailed and step-by-step instructions for every possible scenario. Like for every scenario, the code is being written, the rule is being written. But in machine learning, uh, the algorithms, it automatically identifies the patterns and it gives the results. Like that, like there is no need of manual intervention. The important point is, there is no need of manual intervention in machine learning, because the machine learning algorithm, it identifies automatically the patterns in the data and it gives the results. So this is the first point and first difference between a traditional programming and machine learning. The second difference is fixed logic. In traditional programming, what happens? The code detects how the program behaves and changes require manual updates. So what do I mean by this? So code detects how the program behaves, and like uh, when new data is being given, like it requires manual updates, because in a traditional programming, like the output is being given only for the given particular input. But when the new input is given, the model stucks. So for this problem, machine learning solves this because it uses its logic and it uses its past data to predict a new output for the new input. I repeat, in machine learning, whenever a new input is given, then the machine learning model, it it recalls from its past memory the patterns and logic of the data, and it applies the same logic for the new data also. So by this, the machine learning algorithm and the model, it helps in giving the output. So this was a second difference. So the third difference is, same input always yields the same output. But in the machine learning, outputs often come with a degree of confidence and a probability. So in a traditional programming, when the same type of input is given, then the same output is given. For example, if you want a summary of this PDF, then it gives a summary in traditional programming. But in machine learning, what happens? If you give the input, the summary of that page, then it gives a summary as well as the confidence or a probability. So probability or confidence means like assurance, like it's confident that this output which is given, it is accurate. For example, if I give a summary of uh, AI, if you tell AI like I want a summary of this particular content, then it gives the summary as well as it gives that I am 98% sure that the output which I have given is 98% correct. So this is the third difference between a traditional programming and machine learning. Okay. So the last difference between a traditional programming and machine learning is a traditional programming, it is best for well-defined problems with clear rules. So it is good and best only for defined problems with clear rules. Like if there is a good rule, then like there will be a like if there is a good rule, then there will be a good output. So this is the logic behind a traditional programming. But the logic in machine learning is if the complex problems are given, the rules are hard to define. Okay, so this problem is solved by machine learning by how I told you, because it learns from the past experience and it does the pattern recognition to identify the new data output. Okay, so this was the difference between traditional programming and machine learning. Now next will be seeing what is meant by AI, ML, and deep learning. So basically, AI means what? AI, it refers to artificial intelligence. So as in the name, you can see that there is an artificial intelligence system used to think to think like humans. For example, in a robot, like when we apply AI system, then the robot it thinks like a human, like it thinks similar like a human, and it uses its own logic to produce new and new input, new output. Okay, like whenever a new input is given, then a new output can be created. Okay, so this is meant by artificial intelligence. So basically, artificial intelligence it is used for complex tasks. Okay, now next we'll be seeing about machine learning. Machine learning, like what it does, it learns from past data. It learns from data as well as past data, and it produces the output. Like it learns from the past data, it learns the patterns, it learns the logic, then it gives the output. Now next we'll be seeing about deep learning. Deep learning means what? Deep learning will be having three layers, because deep learning it uses neural networks, and basically neural networks it consists of three layers. So the first layer is input layer, the second layer is hidden layer, and the third layer is output layer. The input layer it allows the input to be given. The hidden layer it recognizes the features and patterns. Then the third layer is output layer, which produces the output. So this is the basic definition for machine learning, artificial intelligence, and deep learning. So I'll be moving to the next part. So basically in machine learning, there are like three types of learning. First one is supervised learning, unsupervised learning, and reinforcement learning. So what do you mean by supervised learning? So basically supervised learning means like there is some support given to the learning method. Like for example, I would say we like the model is giving label data. So what do you mean by label data? Label data means the data is defined properly. As I said before, in spam and non-spam emails, the model is given like the classification labels for spam mails and non-spam mails. Like the mails are defined, like the mails are separated as spam mails and non-spam mails. Like they clearly defined like which mails are spam and which mails are non-spam. And then this same data is given to the machine learning model. So by this data, the machine learning model, it gives the output. So this is nothing but supervised learning. Okay. Now next we'll be moving to unsupervised learning. So what do you mean by unsupervised learning? So basically unsupervised learning means the model, it discovers the hidden patterns, and it discovers the data. Okay, unlabeled data. In supervised learning, labeled data is given as an input, but in unsupervised learning, unlabeled data is given as an input. Okay, so by the unlabeled data, the model should predict whether this is the output or not. Okay, now next I would say is reinforcement learning. So what do you mean by reinforcement learning? Uh, Reinforcement learning means whenever the AI agent, it does or it gives the right output, then a reward is given. For example, in real life, I would say whenever a dog, it follows our command, then we give it a treat, right? Similarly, in AI and ML, whenever the agent, it does the right task given by the user, then it is given a reward. Okay. Else, if the agent, if it does the wrong task, then it learns and it does not repeat to do the similar mistake in future. Okay. I hope you guys understand the difference between supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, label data is given. Label data means the defined data is given. In unsupervised learning, unlabeled data is given. Unlabeled data means the non-defined data is given as the input to the model. And in reinforcement learning, the agent, it learns to make decisions by what? By receiving rewards. Okay, if it does the wrong actions, then it gets a penalty, and it doesn't repeat a similar mistake in future as it learned the lesson in its past. So this is all about supervised learning, unsupervised learning, and reinforcement learning. Okay, so basically, as I told you how supervised learning it works and all, I told you the output, like I told you the example for spam and not spam emails. Okay, just make this in mind. Like supervised learning, it uses a label data, and the example for this is spam and not spam. So this, like, keep in mind, like this would be the this would be an easy example for this type of learning. And in unsupervised learning, data is being given, like no label data is being given. Okay, just keep in this mind. Now lastly, we'll learn like how a machine learning model is being built. So basically, for building a machine learning model, we'll be needing huge amount of data, and that data is should be collected before building any kind of machine learning model. So first, if we want to, for example, if we want to build a machine learning model for stock market, then we should gather the data according to the stock market, right? Now, as you can see here, the data collection is the first process in building the machine learning model. After collecting the relevant data, then we do the data pre-processing. So what do I mean by data pre-processing? So data pre-processing means we are fixing the errors. We are removing the unwanted data. Okay, because those unwanted data can cause errors during our training and testing methods. Okay, So after data preprocessing, a model training is being done. So after doing the data preprocessing, the clean data is fed to the model for training purpose, so that the model can train on the precise data. So the fourth step is model evaluation. So what do you mean by model evaluation? So model evaluation means we are testing the model performance, like whether is it working according to the requirements or not. Is it working correctly or not? Should test that, right? So for this process, it is called as model evaluation. Now the last step we would move upon is deployment and monitoring. So deployment means releasing it in the real world for checking any feedbacks and for checking the working of the model when a real user uses it. Okay, after deploying, just monitor your model, like how well it's working in the real market. Like is like any updates are needed or not, like any errors are there or not. Okay, so just monitor your model and keep updating the model time to time and keep it up to date. Like if we keep the model up to date means then we can then our model will be like well known in the market trend. Okay, so this was the steps for building a machine learning model. So I'll just revise one more time. So first step is data collection, in which the data is being collected. The second step is data pre-processing. The data is being cleaned. The third step is model training. So model training means the model is being trained on a clean data. So the fourth step is model evaluation. So model evaluation means the model being tested, like whether is it working or not. Then the last step is deployment and monitoring. Like after deploying the model, after releasing the model, we are monitoring our model. Like we are checking the model, like how it's working in the real market. Okay. So this is all for today. So we had learned the difference between the supervised learning, unsupervised learning, and reinforcement learning. We learned a difference between these three. Then we learned the difference between a traditional a traditional approach, which is over here, a traditional programming, and machine learning. Then we learned about uh, the machine, what do you call it, the machine learning model building process, right? Which is important because before building any important, like before building any model, like we need to know like what are the techniques and process and what are the things to be done before building any machine learning model, right? Okay, so yeah, like this is all it. So in the next video we'll be learning uh, the machine learning model, like how to train an actual machine learning model, how to build uh, a machine learning model, right? So this all was about a machine learning concept. So in the next video we'll be seeing, as I told you before, we'll see how to build a machine learning model and all. Okay, so I hope you guys like this video. If you like this video, please subscribe to the channel. The channel name is coding is boring and question mark. Okay, and please share it to your friends, family, and any close relatives. Okay, so that's all for today. Goodbye.